Hey everybody, this is your Math Excel video for 7.1. So this is the start of a chapter where it's about exponential functions, and the main thing to remember is that x is the exponent. So previously we've studied square root functions, which goes over to the side and it goes up very slowly. It rises slow rise. And now you're going to compare like x squared, which is like that, to 2 to the x, which goes up even faster, and it stays above like that. And then if it's decay, which we'll talk about in a little bit, it goes like that. So the main thing is that x is your exponent, and exponential functions rise fast, unlike square root. Unless there's a leading coefficient, they go through 0, 1. So for example, if you have 6 to the x, then it's like 1 times 6 to the x, and so that'd be going through 0, 1, because it goes through this a value. Now, continuing with that, it says y values are never negative unless it's a negative coefficient. So that's why you can see it's above the x-axis for both. So other things we talked about before were like your horizontal asymptote would be y equals 0. Your domain would be all reals, which is negative infinity to infinity. And your range would be y greater than 0, which means 0, infinity, with parentheses, not brackets, because it doesn't include 0. Okay, so over here I just pointed out if you had 100 to the x, it would still go through 0, 1. So the 6 to the x graph would look like that and go through 0, 1. So since x is your variable, think about it has to be different numbers, different real numbers. In particular, we're going to focus on the integers. So in this case, 6, 0, which is 1, that's your ordered pair 0, 1. And 6 to the first is 6, and so that's your ordered pair 1, 6. And then for 2 it'd be 36, and so for 3 it would then be 216. And so that's where you can even say on the third iteration it's in the 200s. So that goes up very, very fast. Okay, so the next one says determine whether it's exponential growth or decay, and then the y-intercept. On exponential growth, that's if it's greater than 1. Now, decay is not if it's negative. On the other hand, it's in between 0 and 1. And so you could think 1/2 or 2/3 or 0.75, anything between 0 and 1. Now, if you had word problems regarding decay, it would be about half-life, like carbon dating and things to that nature in science. Exponential growth would be anything greater than 1, like 2 to the x, 10 to the x, etc. And the bigger the number, the quicker it rises. So even comparing that, 2 to the x would be like that, and then 100 to the x would be like that. Somewhere like closer to the y-axis. Now in this particular problem we have 5 times 4 to the x. So your a is 5, and that means your y-intercept would be 0, 5, and your b is 4, and so for the exponential growth we have 0, 5, and so for the y-intercept, because it wants the y-intercept, you just have to put 5 in this problem because they just want a number, like an integer or decimal, not an ordered pair. Other times, use the ordered pair. But on that particular one, you just put the number. So just follow the directions in the problem. The next one is asking if it's exponential growth or decay, and then your y-intercept. So in this one, you have 0.5 times 1/9. It's a little weird to me because you should see like 1/2 and then 1/9 to the x. Because usually if there's a decimal in the problem, the other one would be a decimal. Or if there's a fraction in the problem, then the other one would be a fraction. But this is what we have. So A is bigger than 0 because it's 0.5. And then B is in between 0 and 1 because it's 1/9. And so you're going to have decay. So in other words, that one would look like that and go through 0.5 or 0.5. Now the y-intercept would be your ordered pair, like I said, 0.5 or 0.5. Your next one is a money question, and so I'm just going to say usually money questions round to the 100th, which is dollars and cents, but sometimes to the whole number. So make sure you read your directions. The question on this one says, suppose you deposit $3,000 in savings that pays an annual rate of 7%. If no money is added or withdrawn, how much money do you have in 5 years? So how much you deposit is your initial amount. You'll probably have a different number than me. Also, you'll probably have a different rate than me. But think about if it's like 1 to 9%, then that'd be like 0.01 to 0.09. And so in the problem, you have to do 1 plus 0.07 because you're earning money. Now, if you were paying interest, like on a credit card or a vehicle, I'm just going to put car or house, then you'd have to do minus. So, for example, in this case, I'd have to say 1 minus 0.07, which is 0.93. And so pay for 93%. Okay, so back to this problem. Your initial deposit is your y-intercept. Most of these you just use your table instead of graphing, but if you want to graph it, you'd have to set your y-int to like 5,000 if you graph it, which is just crazy high. So what you want is just to round to the 100th on your regular scratch pad. So you do 3,000 times 1.07 to the 5th, and so that's your answer, 4207.66. So remember, if it's 5 or bigger, round up, and if it's below, then round down. The next part says for 15 years, and so again, just use your scratch pad, change that from a 5 to a 15 to get your answer. Now the next part says how many years would it take to achieve 3,500. So this is where I was saying the best method is to use the table. And so just look in your Y column on the calculator, and if you want 3,500, then you just have to look, and it won't show up as an exact number, but you can see that, you know, between 34 and 3675 is where 3,500 is. So that's where you'd stop. and you just want to round to the whole number, and so it'd be 3. So this is easier than the Y-int equal to 5,000, or not Y-int, Y-max. Same thing over here. I meant Y-max to 5,000, because that would just be like extremely high. And it would go like that. And so this would be the order pair 0, 5,000, 3,000. Okay, so then you'd want your window Y max to be 5,000. So again, make sure you round up, because it wouldn't stop at 2, it'd have to stop at 3 to get 3,500. If you were graphing it, you'd have to do this little thing like that with y2 equal to 3,500, and then do your intersection. Again, that would take a lot of time. For 4,000, you would just continue looking in your table, and this one's 3932 and then 4207. So again, stop, and so it's 5. Okay, now the next one says lower than expected demand for an LCD TV has spurred manufacturers to cut prices in recent years. The average price of a 32-inch TV T years after 2006 can be approximated with this function, 1200 and 0.772 to the T. So this is lower, so that's called decay. So the price went down, so it's called decay. And then it says, what's the average price in 2008? So you subtract these to get 2, and then 2 is your exponent. So you do 1200 times 0.772 squared, which is about $715. But then for 2012, you'd have to subtract to get 6 and plug it in. And this time you get $254. So there's quite a big difference on that. So the price went down later in time, which is what you would expect if it's decay. The next part says write an exponential function to model the system, and it tells you 3 numbers in the problem. A population of 130,000, so that goes in front, grows, so it's 1 point something, 5%, so you put 0.5, so 1.05 per year for 16 years. The first thing you do is just write this part and then sub 16 for x and then round to the whole number. So remember that if it was losing 5%, then you have to do 1 minus 0.05, which would be 0.95. And then your last one says, given the annual rate of change, find the corresponding growth or decay factor. For this one, you have to use the formula B equal 1 plus R. And so if it's 900%, you start by moving your decimal point and getting 9 for your growth rate. And then you have to do 1 plus 9 and get 10. So if it's 700%, it would be 8 for your answer, and so forth. And so if you're growing just 10%, then you'd have to do 1 plus 0.1, so that's 1.10. Alright, so that would be the end of that video. Hope that helps.